So yesterday we learned the basics of vectors. Today we're gonna do applications, and we're gonna be working on applications for a few days. So this is actually a couple days of notes. We're not gonna be doing all of this today. So our goal is to apply vectors to real-world situations, such as model the path of an airplane. And I was actually chatting with the Calc 2 teacher today, and he said they were just doing a test on vectors. So this could be something that you see again. All right, so when we are doing vector problems, there's a few things that we need to know. So the velocity is modeled by a vector whose direction is the direction of motion. Today we're going to be putting directions with those, so north, south, east, west. And the magnitude is the speed. Okay, do we remember what the magnitude equation is from yesterday? The magnitude is the square root of, all right, we'll write it down. Okay, and anytime you hear the magnitude, we're gonna make sure that we associate this with the equation, the square root of a squared plus b squared. Okay, each vector has a horizontal component and a vertical component. And then those can be modeled in vector form or in component form with I and J. Sometimes your book calls this component form, and sometimes they call vector form component form, which I know is a little bit confusing and something that we will practice together. The horizontal is the magnitude times the cosine of theta, and the vertical is the horizontal times the sine of theta. So this is going to be your vector form. Okay, and then the component form with I and J is going to be this. Okay, whenever you are finding the horizontal component, horizontal with the direction is going to be east and west. Vertical is going to be north and south. So sometimes you might, it might say, oh, find the east and west component. That's horizontal. Find the north and south component. That's vertical. Okay? We're also going to talk about today what it means to find what is called the true velocity. And that is where you add the vectors that represent the velocity in still air and the velocity of the wind. Okay, so when you add them together, okay, that is a vector sum. It is called the resultant vector. So it's when you add those together. So you also saw that yesterday, what happens when you add two vectors. Okay, and we are going to set up these vectors on the coordinate grid to determine our values of theta. And that's really nice because it works very similar to our unit circle degrees. When you're finding theta, you are going to use the tangent of theta equals b over a, just like we did yesterday. Okay, the magnitude is the true speed. Okay, to find the magnitude, what formula do you use? A squared, square root of a squared plus b squared. Okay, the difference here is this is where v is the true velocity vector okay, which is what we call the resultant vector. Okay, that's when you add the two of those together. Okay. All right. Now, when I asked you guys a while ago if you knew how to draw the 30 degrees north of east and north 30 degrees east, I think some of us were unsure how to do that. So I'm just going to teach it like you've never done that before. And if you already have from a prior physics class, you will just be ahead of the game. Okay, so what's the difference between 30 degrees north of east and north 30 degrees east? How many of you think you could draw this without me? No one? Okay. All right, then we'll do this together. All right, so you have the north, the south, and the back. Okay, and then you have the east and the west. Never eat soggy waffles. That's how we learn that, right? All right, so if you're doing 30 degrees north of east, you are literally going 30 degrees north of the east line here. Okay, so if you adjust to 30 degrees north, and I'm okay with you estimating. I know some of you have the protractors as your straight edge. Okay, so then this line here represents 30 degrees, and then you're adjusting to the north of the east. Okay, in this case, your theta value, which is something we're going to be interested in, is going to be 30 degrees. Okay, you can also call this a few different things, and we'll talk about that today as well. All right, ready to do the next one? All right, so we'll draw, again, a little grid. If you did not pick up a straight edge, I have them in the back for you. You're going to want one. Not northeast, north-south. Okay, so north-south is our vertical. East-west is our horizontal. All right, and then from there, we're doing north 30 degrees east. So with this bearing, that's what they're called, the bearings. If you have north 30 degrees east, you start north, and then you adjust it 30 degrees to the east. Okay, so this angle is 30 degrees. And the theta value is just like the unit circle where it always starts from 0. So from here to here, what would your value of theta be? 60. Oh, you're in band. Oh, yeah, you gotta go. Okay. All right, and then we're gonna say this a few different ways. Yeah, so you take it. All right, and then, like I said, there's a few different ways that you can write these. So another way that you could say north of east is you could say you start east and you go 30 degrees to the north. Okay, and then You could also say, if this is 30, we know this is 60. You could say north 60 degrees east. Okay, so based on that, can you write two different ways for this one here? All right, so for this, we should have north. Oh, I was going to say north 30 degrees east. That's what we have. You can have east. So you start east and then you adjust 60 degrees to the north, or you can say 60 degrees north of east. Okay, a lot of times we'll use the north of east. You'll see that in your book, but they'll be written both ways. Okay, so for all of our story problems, we're going to do a diagram. So in example 1, it says an airplane is flying in the direction 15 degrees north of east at 550 miles an hour. A wind is blowing in the direction 15 degrees south of east, okay, at 45 miles per hour. What we have to do is find the component form of the velocity of the airplane and the wind. Okay, so you have the airplane and you have the wind that you have to find the velocity for. Okay, velocity is going to have a direction along with the speed, so it is always going to be written as a vector. Okay, we're going to draw our picture over here. And we're going to start with our bearings. Now, when we draw the picture, the speed is the magnitude. Yesterday, we talked about the magnitude is the length. So the length of this vector should be 550. Okay, and the wind would be 45. Okay, so about how many times larger should this vector be compared to the 45? Yeah, about 11 times, right? At least 10. So we do want to draw an accurate picture, but we also understand there might be a margin of error there. The more accurate your picture is, the more accurate the angles are going to be that you have to find. Okay, and I'm going to start with our grid. Okay, so if it's 15 degrees north of east, okay, that means you're adjusting 15 degrees north of the east line. Okay, so if this is about 30, about half of it will be the 15. And if it's 550, I'm going to make that as long as my paper will allow, because it's supposed to be 11 times bigger than the other one. Okay, and the way that you label it is you label it with the magnitude, and then we'll call it A for airplane. Okay, so the magnitude is the speed. Okay, 550 is the magnitude of your airplane. So let's go ahead and find that vector. Okay, so here it was 15 degrees. That is going to be equivalent to our theta. Okay, the magnitude is the speed, 550. So when you write out the vector, it's going to be 550 cosine of 15 degrees, 550 sine of 15 degrees. Okay, so make sure that your mode is in degree mode in your calculator, and we will round to the nearest hundredth. So we're always going to be rounding there for these first few units just to keep that uniform. Yeah. Yeah. Do you want to borrow this one? You can just put it on there and then for this one, we'll do the sine. All right, so what we just found is the velocity of the airplane. Okay, I'm going to be reaffirming some of these vocab words because when people get to a quiz, they start second guessing. Oh, it's the velocity of the airplane. Which one is it? Okay, so we're going to be working a lot with velocities. There's velocity of the airplane, velocity of the wind, and then we're going to find something called the true velocity. Okay, so just having these reinforcements in your notes is going to be helpful. All right, so for the wind, we're going to find what the theta is after we draw that, and then we know the magnitude of the wind is the speed. So the magnitude is the 45 miles per hour. Okay, so it says that's in the direction 15 degrees south of east. So if you're going south of east, it's going to be in quadrant 4. Okay, and then I am going to try to make this as accurate as possible, but this is going to be very small compared to the 550. Let's see, it's about the size of my nail. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe I could make it a little bit more. I guess using my nail is not an exact science. Okay, and then from here to here, what would my theta value be? If this is 15 degrees, what's your theta? So think of the unit circle, right? This is 0 degrees here. So if I'm going 15 degrees to the south, what is going to be my theta? Yeah, so you could use that. Yeah, you could use 345 or you could use negative 15, either one. Yeah, great. Okay, and then one other thing you just want to notice is when you get this vector, it will match your quadrant. So this is positive, positive. This is in quadrant 1. Okay, so that should match. And then for the wind, let's calculate that. Okay, so you have the magnitude times the cosine of negative 15, and then the magnitude times the sine of negative 15. Okay, so I want you to calculate those and then simplify. Okay, and I'll just show you that it does not matter if you use the -15 or the 345. You will get 43.47. Okay, and then Gabe, let me know what you get for the vertical component.
-11.65.
Good. Now, once you guys get that, ask yourself if that makes sense in context of the problem. This is a positive negative. This is in quadrant 4. Okay, so that does match our drawing. Okay, so this is the velocity of the wind. All right, now we are going to find what is called the actual speed or ground speed, and we're going to find the direction. And I said hint, don't forget the wind, but I'm not going to let you forget it. We're going to talk about it. So anytime you're finding the actual speed, there's a few different names. It might say actual speed, it might say ground speed, or it might say true speed. All of those mean the same thing. Okay, so that is the magnitude of the resultant vector okay, and the resultant vector is going to be a vector sum. Okay, so in this case, the resultant vector consists of the airplane plus the wind. So yesterday you learned that when you're adding vectors, you only have to add the horizontal components together and the vertical components. Okay, so you can add the 531 and the 4347 because those are both the horizontal components. You can either take the exact values or the rounded values. Okay, so you're adding the horizontal components. Now we're going to add the vertical. Okay, so go ahead and add those, and then you'll be ready to find the magnitude. All right, and then Elliot, what'd you get for the vertical component? Yes, good. So, and I think if you use the exact ones, it says 0.7. The rounded one is 0.70. So great job. Okay, and then the actual speed is the magnitude of this vector. Okay, so magnitude equals true speed. Okay, so when we write out that we're finding the magnitude, we're using our proper symbols. We are taking the square root of 5.7473 squared, and this is something that you can input into your calculator all at one time. Okay, so we can find our actual speed here. And you can use the square button just like you do for the F squared. Okay, and this is in miles per hour. Okay, so include your units. So 589 miles per hour. Okay, now we're going to find the direction of the airplane. So in order to do that, we are going to put on our diagram the resultant vector. So yesterday, you guys learned that the resultant vector is the diagonal of the parallelogram. Do you guys remember highlighting that in your notes yesterday? Okay, so what we're going to do is we are going to make the parallelogram and then we'll do the diagonal from there. Okay, so the parallelogram is like this here and this here, and then your diagonal is going to be that vector. Okay, so that's what we're going to do. And in order to do that, we're just going to use our straight edge. So if it's a parallelogram, these are parallel. And we're just going to do a little dash here, little dash there. Okay, and then it goes to this opposite end. Okay, so this is your true velocity vector. Okay, so true velocity or the resultant. So we call that A plus W. And based on this picture, you can see it's in quadrant 1. Okay, which means your theta value should be a degree in quadrant 1. And see how it's in front of this line? That means the degree should be less than what? 15. So our answer should be between 0 and 15. Okay, there might be a little margin of error because if it's not exactly the 11 times. Okay, so when you're doing the direction, what you're finding the direction of is that resultant vector. Okay, so to find the direction, we're using the tangent of theta equals, and it's the B over A, but let's plug in what that is. All right, so I'm just going to draw a small picture here to represent that. This is your A plus W, okay, from here. What you have is a right triangle. In the right triangle, when you are solving for theta, the tangent is B over A, right? Okay, so the B is the vertical component, the A is the horizontal component. That's what you found here. This is your A plus W. So A is the horizontal, the 574.73. Okay, B, the vertical, is 130.70. So when you set up this fraction, okay, the B is 130.70 over the 574.73. We can also think of that as the opposite over the adjacent. Because remember when we learned tangent, it was opposite over adjacent? That's the same thing we have here. Opposite over the adjacent. So to find that, we're just going to have to use what? To find the measure of this angle, we just have to use our inverse tangent. And when you guys are doing this on your own, if you just want to jump to this step, that's fine. Okay, so we're going to do our tangent inverse. Okay, and we get about 12.81 degrees, which is great because we said it should be less than 15 and in quadrant 1. Whenever they ask you to find the direction, you must include your bearings. So that's your north, south, east, west. Okay, so there's a few different ways that we can write this. So we can write 12.81 degrees north of east. Okay, or you want to write east 12.81 degrees north, you can do that. Okay, so either one of those would be great. Okay, and then when you're ready, you can go ahead and read through example 2. All right, so we have another plane. It's traveling north. Okay, so we're going to have to make a picture with that, and then we have a 38 miles per hour crosswind flowing in the direction north 60 degrees east. Okay, we have to find the true velocity. So whenever they are asking you to find the true velocity, okay, you are going to be finding that resultant vector, which is the velocity of the object plus the force. Okay, so true velocity is the resultant vector, that is the sum. It says express it in component form and in terms of I and j, so we're going to express it in both forms. Okay, and then we'll start with the airplane. So we're going to draw a diagram. Okay, so for all of these, I want you to draw a diagram. Okay, if you don't have a straight edge at home, you can do the best you can. Okay, or you can just use a note card. Okay, if you don't have a ruler or anything. All right, so north, south, east, and west. So if it's just traveling north, okay, it's just going to be the same as this line here. Your 280. Okay, so we're going to label that. And then the 38 miles an hour crosswind flowing in this direction. Okay, so if you're trying to figure out, oh, how much larger is one than the other, just divide them. 280 divided by 38. Okay, so it should be about 7 times larger. Again, it does not have to be exact. It will just give you a more accurate value of theta, of where your theta should be. So if it's in north, 60 degrees to the east, then this angle here is going to be 30 degrees. So we know this angle is 60. Okay, so this is the wind. That's going to be a magnitude of 38. And we have to think about what our theta values are. So when you're finding your theta, think of this as 0. Okay? For the airplane and this, think about what your theta is. So right now we're with airplanes and wind, but we are going to be working with other objects. So the true velocity is the velocity of the object plus that force. Okay, so it's the resultant vector, it's the sum. So we are going to find the velocity of the airplane and the velocity of the wind. Okay, so the magnitude is the speed. I'm going to do the cosine of the angle and the sine of the angle. And we'll simplify that together. And then for your wind, your magnitude is 38. We'll simplify. Okay, so go ahead and write in what your angles are and then go ahead and calculate them so that you have them in simplest form. Okay, so Gloria, what'd you get for the angle of the airplane?
0.
But what was the angle? Yes. Okay, so if you're starting at 0 and you're going to the north, isn't that just a right angle? So 90 degrees. Okay, yeah, and then when you multiply, the cosine of 90 is 0. So that means the first component is 0. What is the sine at 90 degrees? 1. Yep. So then when you multiply, you'll get 280. So this is the velocity of the airplane. All right. And then, Kinley, what'd you get for the angle for the wind? Not 38, but so if this is 38 is the magnitude. So if this is 60, this angle here is going to be what? Yeah. All right, so if this part is 60, 60, and 30 is what would add up to 90. So then here you would have, for 30 degrees, you'll have a decimal because it's root 3 over 2. So you get 32.91. And then the sine of 30 is a half. So what's half of 38? 19. And is that what we got? Okay, so this is asking you for the true velocity. So the true velocity is adding the airplane plus the wind. Okay, so when you add the horizontal components, 0 and 32.91, you will get 32.91. And then when you add 280 and 19, you will get 299. And then it also said to write it in terms of I and J, so we're just going to do that as well. Okay, so this is the true velocity. Okay, now it also says then find the true speed. So true velocity is a vector because it's going to have direction. The true speed is a scalar value. It is just the magnitude of the true velocity vector. Okay, so remember true speed, it's the same thing as actual speed or ground speed. Okay, so whenever they say find the true speed, they mean that you have to do the magnitude of this true velocity vector. Okay, so we're going to do the square root of 32.91 squared plus 299 squared. And then I want you to calculate that, write it on your paper. I will come around and check that. And once you've done that, go ahead, read through example 3. Okay, and I really do feel like you could do all of example 3, but let's first make sure you have the velocity of the wind and the velocity of the jet. And it says that you're expressing them in both component and vector form. So that just means you're writing it as a vector here and is the component form, which I mentioned yesterday that your book interchanges the name of component form, which I don't like. If I want you to write it in terms of INJ, I will say that. But if it says write it in both forms, those are the two forms we're going to be working with. Okay, so calculate your true speed and then go ahead and do these, and then we will draw the picture together. Okay, you have a little picture here that's enough for you to do your A and your B. Okay.
See, that's what I was just doing.
Okay, so I said you guys do A and B, and then we'll draw the picture together. Okay, and you guys did a nice job of finding the true speed. Make sure you have your miles per hour. Okay, so when you're doing the velocity of the wind, okay, it says it's a wind that is blowing with a speed of 55 miles per hour, and then this is the direction. Okay, and I said you could use like this little picture to help you, which means your theta is going to be what? Yes. Okay, so your wind is the magnitude times the cosine of 60 and the magnitude times the sine of 60. Okay, so we get 27.5 here. We get 47.63. Okay, and it does say in both component and vector form, so we just express it in both forms. Okay, so this is the velocity. Okay, and then the velocity of the jet relative to the air, okay, as a vector in both component and vector form. Okay, when it says relative to the air, it means without including that wind. Okay, so for your jet, they tell you that the speed is 765 miles per hour relative to the air, and the jet is heading in this direction, north 45 degrees east. Okay, so again, with this picture, you can, here we saw that this was 60. Here we're going to see that theta is, what's your theta going to be? What is your theta going to be? Okay, and it's because you're always going from this east value. Okay, so it's 765 cosine of 45 degrees, 765 sine of 45 degrees. Okay, so let's go ahead and calculate. Now, at the 45 degree mark, what do we know about the point at pi over 4, 45 degrees? What's the point at pi over 4? Yeah, they're the same thing, root 2 over 2, root 2 over 2, which means, guess what? These two should be the same thing too, because aren't you just multiplying by the same? Yes. Okay, so terms of I and j. Okay, and then when you are finding the true velocity of the jet as a vector, that is the resultant vector. Okay, so the true velocity is the jet plus the wind. Okay, we call it the resultant vector. It is a vector sum. Okay, so our vector, we're going to add 27.5 and the 540.94, which will give us 568.44. And then in the vertical component, I'm going to add 47.63 to the 540.94 to get 588.57. Okay, and then we're going to find the true speed and the direction of the jet. Okay, and we are going to draw a picture of that to help us. So when you are finding the true speed, that is the magnitude of the true velocity vector. Okay, so we do 568.44 squared plus 588.57 squared. I know I forgot to put my square root in. I'm going to square those and then square root my solution. So 818.25. So if the speed is 765, but the true speed is 818, that wind is helping push you along, right? You know, sometimes you're on a plane and you arrive earlier than scheduled. Got that wind helping you along. Okay, that's your true speed. So when you're doing the direction, remember we have to put our bearings on there. So we're going to draw a picture so you can see where that resultant vector is. Okay, so we're going to just draw this on the side. So north, south. Okay, so if it's 765 and it's at the 45 degrees, I always just draw that as half of my quadrant because 45 is going to be half. Okay, and then because it's such a large number, I try to make that a long vector. So that is my jet vector. Okay, and then I had 55. Okay, so that's about 13 times as large as my other vector, which is going to be 30 degrees in this direction. So I have I don't like that. That looks more like 15 degrees than 30 degrees. Okay, and then that is my wind. All right, and then when you are writing where that resultant vector should go, you can use this as your parallelogram. If you don't want to put, if you don't want to do the dashes, you can kind of see where the point's going to go for the diagonal, and you can just draw it to that point. Okay? So this visual is helpful because now you can see that your theta value for the jet plus the wind should be larger than 45, okay, but it should be less than 60 based on our picture here. Okay, so to find theta, you can use the tangent inverse of b over a. Okay, and then you're using the 588.57 over the 568.44. Okay, and when you calculate that, let's see what we get. Okay, so this is going to round up to 46.00, and then you can write this as 46.00 degrees north of east, or if you want to write it as east 46 degrees north, you can also do that. All right, your homework tonight is going to be 5 questions. The first question is going to be part E. So you are going to have to do part E from your notes. Okay, so you're finding the true speed and the direction of the jet in the same example. If the direction is north, 45 degrees west. Okay, so if you are drawing this picture, okay, remember, this is the hint I'll give you. Your theta value always starts from 0. So you have to find your theta value. If this is 0 degrees, once you draw your picture, you have to find the angle starting from there. Okay, so that's the first question. And then the other ones are going to be from your textbook. It's page 588. And I'm going to put them up on the board. Okay, so 588. And it is 54, 58,